Okay, this section's about linear relationships and determining if you're given a table, an equation, or a graph, if it is linear. So just take a moment, hit pause, and copy the table, copy the equation, and copy the graph. The graph is simply those table of values. So 1, -1, 0, 1, 1, 3, and 2, 5. So go ahead and copy those now. Okay. These are three ways that linear relationships can be represented. A linear equation is where you have x to the first power and y to the first power. This is slope-intercept form. You don't have to have it in this form, but as long as x and y are to the first power, that's a linear equation. A graph, ignore these. A graph, when you graph these table of values, if it makes a straight line, it is a linear relationship or equation. And table of values. Your slope or your gradient here, your change in y over change in x, this is called delta. It's a Greek letter. It means change or the differences in your y's. You normally would see it like this. The differences in your y's. Well, what's the difference from -1 to 1? 2 over the differences in your x's. 1, as long as that's consistent the whole way. Then yes, it's a linear relationship. So these are three different ways you can see that. I want you to pause the video and ask yourself if these 4 examples coming up are linear or not. Go ahead and do those on your own. This one, you would have answered yes, it's in slope-intercept form. The next one, no, the highest degree is 3. Here, x is technically to the first power in the denominator, but it's to the -1 power. In your graphing calculator, you could have done this too. If you wouldn't have seen a table and you couldn't tell by the equation, you go to the graphing calculator, you turn it on, you go to the y equals equation, and you hit X. X is in the middle of your calculator. There's a button and it says XT theta N. You hit that button for X. Then you raise it. There should be like a caret button, a button that looks like this, to the -1st. And then in the top right corner, you press graph. You're gonna see a graph that looks like this. That's obviously not linear. Okay, we'll talk about that in chapter 2. Here, it is actually, oh, this is referring to this. We'll talk about that in a second. This is linear. The change is 3 over 1. 6 over 2, which is 3. 12 over 2. I'm sorry, 12 over 4, which is 3. I was thinking about this. Yes, there's what's called an asymptote here, a barrier. If there's an invisible barrier, that's called an asymptote or an asymptote. We'll talk about those in later chapters if people are wondering, because some people knew what that was actually. All right, next page. We're talking about linear equations of a line. Standard form of a linear equation is ax plus by equals c, where a and b and c are integers. I do apologize. Hey, we'll get it in a minute, okay? Anyway, a has to be positive. So when you have homework tonight, if a is not positive, multiply everything by -1. Your GCF has to be 1, and they have to be whole numbers. So I need to see a positive number. This can be negative, that's fine. And so can this, it doesn't have to be. But it has to be whole numbers. If I had something where it was like 10x minus 8y equals 12, I'd have to remove a 2. So make sure when you're doing your homework tonight, x comes first, it's positive, the GCF is 1. When linear equations are written in standard form, a quick way to sketch them is their intercepts. Okay, so wherever we intercept a graph, on the x and y axis, those are intercepts. I intercept y at its axis, I intercept x at its axis. Okay. Just ignore that line. So x-intercept is when the x-coordinate of the point crosses the x-axis, and here's the y. Every single time, what's going to be the x value for your y-intercept? 0. Your x-intercept, it didn't go up or down. Every single time, its y value is going to be 0. So to find the x and y intercepts visually, you just made a coordinate. If you just said 6 and you just said -3, that's not incorrect. But I encourage you to do this so you realize, you're getting more practice realizing 0 needs to be in the other value. So when you get to a problem like this, I tell you to find the x-intercept, you're going to put 0 in for x, and you're going to find y. And then when I tell you to find the y-intercept, you're going to put 0 in for y and find x. So that's going to disappear, and your y value is going to be -5. And that's how you would find the intercepts algebraically. The next problem asks you to use the intercepts to graph. I'm going to have you pause this, and you are going to do this one on your own. Okay, I hope this is what you got. So that's one form, standard form. We don't use it as much as you're probably going to use slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept. So an example, y equals 5x plus 2. An example, y equals 0x plus 7. We would never really write it like that, but if you have a 0 slope, it's just going to be y equals 7. Okay. Y equals -1/2 x plus 0. We don't really write the plus 0. Non-examples, standard form. Non-examples, any other form that isn't slope-intercept form. The slope of a line is called the rate of change, and it describes the rise over run. It is defined as y2 minus y1 over x2 minus x1, or change in y over change in x, which is also called delta y over delta x. Example 3 wants you to find the slope of the lines given the points. Well, you could just visually see it, but I want you to get in the habit of labeling your points and then using your equation, -2 minus 6 all over 0 minus 2, and finding the slope here. Okay, a way you could do it on a test is to plot your points and check your work. Is it kind of steep and is it positive? Then it's 4. Here, if they give you 3 points on a line, all you need is 2 of them to find the slope. I'm going to pick the positive ones just because it'll be easier for me to see visually. And then you reduce. Okay. This says use the slope and y-intercept to graph. Well, this is in slope-intercept form. This is not. What? Wow, thank you. Be careful. I'll be right there, okay? Did you rip that off?
Yeah.
Honey, please don't rip that, okay? It's okay. I'll be over in a minute, okay? Say good morning to everyone. Okay. All right. Use the slope and y-intercept. So here, you move 3x to the other side, divide every piece by 2. This is in slope-intercept form, and so is this. So you begin with b, and you move with m. Begin at -2, Go up 1, 2, 3 over 1, 2. Up 1, 2, 3 over 1, 2. You graph your line. Then you kind of self-check. Do I have a positive slope? Yep. Did it begin at -2? Yep. Pause the video, try this one on your own. Yep. Negative slope, you begin at 2. All right, last one. Write an equation of the line. Slope-intercept form. Well, slope-intercept form is y equals mx plus b. So all you need to do is find a b, and you need to find a slope. Your b here is 3. This is the last time, guys, I swear. Wow, what is it? He doesn't like the video, that's why I keep doing it. Okay, you go down. Look. 1 second, Ezra. Go down 3 over 5. I see it. It will be a lot clearer on your test. Here, you begin at 5, and your slope is 0. You can write the word 0 if it's a 0 slope. If your slope is this way, 1 second, honey, then you write no slope. Okay? All right, I hope that helps and that you could hear the end. I apologize. I want you to do this sheet on your own. Pause this video real quick. Don't mind my laundry. When you are